Hello, guys. Today we are covering 710 reflections, which is just like a reflection in the mirror. Okay. So these are called transformations. So we'll do a little talk about that first. A transformation is an operation that maps an original figure called the pre-image. So the original is referred to as the pre-image, and the new figure called the image. So you're going to hear that vocabulary, so make sure that you understand that. Okay. A transformation can change the size, position, or the orientation of a figure. So it can change the size, position, or orientation of a figure. There are 4 types of transformations: translations, reflections, which is what we will talk about today, rotations, and dilations. So let's talk about reflections. The reflection is a flip. It flips over a line called the line of reflection. Each point and its image are the same distance from the line of reflection. So it's the same distance, both the point and the image are the same distance from the line of reflection. Normally, it is reflected over the x-axis and y-axis are common lines of reflection. They're the most common ones that we see. Reflections result in congruent polygons. So reflections give us congruent polygons, same size, same shape, same measures, and same side lengths for the angles and sides. So let's look at number 1. So the first thing we have to do is plot these points and draw the figures. So we have to graph and label each figure and its image under the given reflection. And then we have to write the new coordinates. So the first thing we're going to do is plot these points. So we have 1, 6. This is the x-axis. This is the y-axis. 1, 6. So this is 1, 2, 4. Like 1, 2, 3, 4, 5, 6. So this is A. B is at 8, 3. So this is 2, 4, 6, 8, 3. So there's B. And C is at 4, 2. 4, 2. So there is C. And now we connect those dots. A goes to B, B goes to C, and C goes to A. So it makes that triangle. Now, the new image, okay? The new image is reflected over the x-axis. So therefore, I'm going to highlight the axis that it is flipped over. And now we're going to see, okay, C is, remember, it said it's the same distance from the line of reflection. So this is 1, 2. So I'm going to go 1, 2, the opposite direction. There is my C, and we should denote the new image with this little apostrophe. So B is 1, 2, 3 away. So I'm going to go 1, 2, 3 down. A is 1, 2, 3, 4, 5, 6. So I'm going to go 6 down. 1, 2, 3, 4, 5, 6. And there's A prime. And this one is B prime. And now we play connect the dots. And now I have graphed my new image. Now I need to write my coordinate planes. Not my coordinate planes, my coordinates, my new coordinates. So A is going to be, it's still at a +1, but now it's not above the x-axis, it's below. So this is at a -6. B is still at 8 on the x-axis, but instead of being above and having positive y, it's going to be below and have a -3. C is still at 4. Instead of being above and positive, it's below and negative. Next example. So looking at number 2, first things first, we got to plot the points. So we have 2, 1, and that is J. And then we have K, which is at 4, 7. 2, 4, 6, 7. So this is at K. I think my J, I need to put over first. And then we have L, 7, 6. It's 2, 4, 6, 7. 2, 4, 6. And that is L. And then we have M, which is at 5, 0. 2, 4, 5. And that is M. So now we play connect the dots. To make our rectangle. And this is flipped over the y-axis, which is this axis here. So again, they're the same distance. So I'm just going to count how far. So J is 1, 2 to the right. So now I'm going to go 1, 2 to the left. And that is J prime. And that coordinates are going to be the same y value, which is 1. And then it's at a -2 for the x. Okay, so for K, it is 1, 2, 3, 4 to the right. So it's 1, 2, 3, 4 to the left. So this is going to be a -4 and a +7 because it stayed at the same height. Okay, so L is 1, 2, 3, 4, 5, 6, 7 to the right. So therefore it's going to be 7 to the left. 1, 2, 3, 4, 5, 6, 7. So that's a -7, and it's still 6 high. And this is L prime. And then we have M, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left, and that's M prime. So this is -5, 0. And then, yes, we have to play connect the dots. You have to draw the new shape. And there we go. Moving right along. We're going to go to the next page and jump down to the bottom where we're going to talk about what was the rule, which you may have kind of figured out by the way I was discussing things and figuring out the coordinates. So the rule when we do this, if it is reflected over the x-axis, that rule is going to take the image, the new one is going to be the same x value, but it's going to be the opposite y. So this is the opposite y value. That is when you're reflecting over the x-axis. When you're reflecting over the y-axis, it is the opposite x, but the same y. So this is the opposite x value. All right, let's look at number 11. Okay, so we're given triangle LMN with these vertices undergoes a reflection with the new coordinates. So I'm going from this coordinate to this coordinate. I need to think about what happened to the coordinates. Oh, well, the y's stayed the same. The x's became the opposite. So x's are opposite, y's are the same. Well, based on that, which rule does it apply? Opposite x values, that means it's reflected over the y-axis. So you would write capital R. You don't have to actually, not capital R. Lowercase r, and then subwise, you write y, reflection y-axis. This is your answer. If you have any questions, pause and rewind or come and ask a question. Have a great day. Bye.